start recording. We're providing a summary of what we have done yesterday in terms of the universal axis, the 2-inch version, which means the heavy-duty version. So William, go ahead.
Okay, so yesterday...
Do you have video on yours so I can actually share yours?
Okay.
Your video view?
I'll put video on here. Share screen.
Which one are you? I'm not... You're hello?
And... which one are we? That's it. Yeah, hello.
Are you sharing mine?
I've seen in Spaceballs. What part of the movie is this?
So
It doesn't want
that's me.
It doesn't want me to share my screen. Oh, here we are. Entire screen. Here we are. Allow. Oh, that's good.
There we go.
We're descending to infinity. Hold on. This will just take a moment.
Oh yeah, I love it. Alright, try that. Try that file.
Ooh, let's just make that
We're gonna crash it, I
Same
think.
wiki page.
Infinity and
Different
beyond.
link on the same wiki page.
Okay.
Bye-bye! Oh, okay.
Bye-bye.
Is that showing? It says it's sharing my screen.
Yeah, we got it.
Okay.
Oh, yeah. So, yeah.
Is it working
that's
now?
good. Yeah, but he had just started a new file, which is... There's some bugs on the wiki, man. So...
So, yeah, yesterday we went fairly far in one day. If you consider that we started FreeCAD from scratch for many of our participants. None of our participants have an engineering background. They're from all different walks of life. And we went through a very intense process to go from 0 up to making parts very quickly. There are lots of little things to learn in FreeCAD. So we went through making a sketch, extruding it into a 3-dimensional shape, adding a feature like an extrusion, which is called a pad, or a pocket, which is a hole, and learning the vocabulary of FreeCAD, because I still call it an extrusion, not a pad. And then we went through the process of looking at, okay, what is the universal axis we want to design. And it's really confusing and challenging when we have many people and we have a short amount of time, how to reconcile everyone's points of view and get to a final product. So the objective is to have a universal axis that we can manufacture in the first few days. Our challenge is we need to get FreeCAD for a number of participants so they have the basic skills. We have to get some engineering going, so we don't want to just make something that's not going to work. And then we have to actually get to manufacturing it and sharing it online and collaborating. So we went through a process of just making some very basic definitions of the universal axis. And so we've defined two 2-inch rods as the backbone around which we're going to build everything else. We also chose a separation between the rods based on a few parameters. The width of the printing allows us 7 inches wide as the maximum size of a 3D printed clamshell part. And then the 2 inches of the rods and the 2 inches or so of the size of the NEMA 23 motor pretty much constrains us to a certain dimension, 7.5 inches wide. With certain separations, we put 3/8 of an inch on either side to give some space around them, and then enough space for the motor in the middle with another 3/8 inch between the motor and the rods. So that's the basic interface configuration we set upon. So that's what they do in WikiSpeed, where they divided a car into 8 modules and had teams remotely design these modules and defined how they were going to fit together. And this is a much simpler idea here. It allows us to go off onto our own as long as we keep to the idea that these rods are a certain distance apart. We can all work independently. So we got one part that was designed by one group of participants, or maybe it was Tiffany, I can't remember. It's Tiffany. And we brought it in here and learned how to assemble it together with the help of Aiden's insight about the assembly.
You actually used assembly?
Yeah.
A2 plus.
A2 plus, which is a sort of assembly stepped up a little. Yeah. So
Was your experience good with the workbench?
yeah, this is way better than the other one. I was working for 15 minutes and got nowhere. In the other one, I worked for about 2 or 3 minutes with Aiden with this one, and it was just fine.
Excellent.
So this will very easily become an assembly that represents our final product. Right now we just have boxes with holes. So our next exercise today is to use our ability to create features and then to consult with Marcin and everyone else on the team about what are the requirements for the various features. So this is our idler placeholder. The idler will need a set of gears in the middle, or pulleys in the middle that handle the 3 belts. It'll need some screws to hold it together. It may need a clip for an end stop if we choose to put it there or not. Depends on our design decision. And so that's our idler. So now 1 or 2 friends can work on that.
I would like to request 4 bolt holes in there because that has to attach to a frame unless we don't get there.
So bolt holes that are separate, that are just available for attaching to other
For
things.
half-inch
right?
bolts.
At the end, you mean?
No.
Or on the...
Because this is going to go on a... Say this is the y-axis.
Yeah.
That's to attach to the frame.
Yes.
If this were attaching as the x between the 2 y's, you'd need nut catchers.
We could also
there.
put nut catchers there if
Yeah.
there's enough space, because it's going to be fairly big. So it may be big enough to put some of those things in there.
Yeah.
So we'll see. Now there's an interesting thing that we heard yesterday in our consultation. Michael's an engineer. And from an engineering point of view, it was kind of not so satisfying to see the way we're doing it. But it's always good to listen from that side. Like, we're focusing on collaborative literacy and bringing people on board to get collaboration happening. But where possible, we should be cognizant of avoiding doing work twice and thinking ahead as much as possible. So, can we do this in the short time frame? That's the thing that we need to do. We need to keep many things in line. Yesterday I suggested we just do the box and hole approach, so we can go all the way through the process once on a very basic level and come up with a conceptual design. Then we can go back to our same models. We don't have to start over completely because we already have the basic shape that's constrained by the rods. Then we can start adding things into the components and get to where we need to go.
Features.
Yeah.
What are some insights regarding how we can apply more engineering concepts here?
Well, one of the insights was to get a whiteboard and put a common vision of what we're doing up here just before we begin here as a group. Now, that is what we do in an engineering firm when we're all around in the same room. In OSE, we may have collaborators in Australia. And Marcin has pointed out, if we do that here, then what if someone is in Australia and staying up all night to be with us and then can't look around the camera angle to see what's going on the whiteboard? So there has to be balance. But if we're here, as long as we draw something quickly and put it right up, somehow maybe we can balance it. I don't know.
Yeah, but I don't see any reason, like, yeah, we can do some stuff here, but always the world outside is bigger.
Yeah.
So I don't see any reason why we cannot use the Google Docs with very simple sketches.
Mm-hmm.
Because then the people who are remote, maybe they refine them. We're missing the thing that bothers me. We could be missing all this input from elsewhere because it's not out in the cloud.
Mm-hmm.
I really want to emphasize that point because it's much bigger than what we are here.
And here's something, like, when we're accustomed to something, then sometimes we are not able to see the other possibilities, and this happens with a lot of things in life. Education, we're accustomed to rows of desks, so it's very uncomfortable. Even if someone wants to change it, if you want to change that, it's very uncomfortable. So this is something we're striving to see, well, what is possible. So maybe we can try that.
We did a 360 camera also.
Yeah, we could do that. That could work. So there are various ways to solve this problem.
Yeah.
We'll see what we can do today to reconcile multiple viewpoints in a short amount of time, without hurrying and yet having a sprightly pace. So maybe we can break into our groups again and do this, but maybe we should have like another design engineering session around this. One way I could see of doing it, I could put Blender on here and very quickly generate this in Blender to get us something that could be labeled and put into the working document.
Blender, why?
Blender is very quick to just extrude 3D shapes all at one place.
A quick.
It's
Are
very
you set
quick
to get diagrams?
to get a very quick 3D diagram.
You mean like with labels and stuff?
Yeah. So we
Okay.
just do the 3D diagram first, then put it into the wiki working document, and then put the
Okay.
labels on.
Okay.
So I think
Because
that
I'm
might
wondering
work.
why you don't want to just put it like maybe like use the dimensioning workbench here to just put labels on
Because
it.
this takes so long. Blender, you can just.
Okay. So okay.
Yeah. So that's one
That's
thing.
consistent.
We're going to make just a not to scale, but a logical, conceptual. Basically, draw the universal axis in Blender, and then put it up and label it in the
Okay.
FreeCAD.
Yeah.
Because one thing, sometimes people don't see the whole picture if it's a 2D diagram.
Yeah,
so.
yeah. Okay, great.
That's one
And that's a great
suggestion.
example. It's like if we've got extra energy, there's no conflict for people taking on the tasks that are necessary, so that the conflict resolution is very easy. It's like, do it and contribute it to the pot. Great. So let's do it without hurrying, yet at a sprightly pace, as William said. Okay, and then the other team is free to go to the workshop and continue on the printers. Is that so? Mm-hmm. Okay. Great. So we'll stop this. So we're doing this collaborative design process. Several people are designing, other people are in the shop, and stuff is getting done. And if you're remote, take a look at the 2-inch universal axis page. So let me just point you to that, because this is going up online. So right now I can actually contribute to informing more people in the outer world with what's going on here, so possibly somebody can make a meaningful contribution. So I'll just walk over, go over the 2-inch universal axis page, what's there. So 2-inch universal axis page on the wiki, I can actually put that into the Jitsi meet for people who are there. And I'm recording this so many other people potentially can take a look at it. There's a working doc that we have at the very top of the page, and we've identified basics of main features that are required. Right after that page, we started to divide the different parts that we're working on among people. So we've got different people and links to the files that they have generated. Like, for example, William, even just Aiden. Okay, yes, Aiden's got his link to the part. We started seeding a part library where you can download the actual parts that we are generating in FreeCAD. And in the working document also there's some basics on how do you design the connection of the stepper motor to the drive belt system through a coupler. We're using 3 15mm wide GT2 belts, which can be shown in the bill of materials. There's some of that in the bill of materials. Basic concept, you have a shaft coupler and you're putting 3 pulleys on that and making this work. Now I also took a look at some of the basics of what the physical constraints are here. What is the actual print time? Well, people, if we do 20% infill, it takes 4 hours 15 minutes to print the part that is 3 by 3 inches by 7 inches. This stuff.
Wow.
So but that's 2 clamshells, so each clamshell will be half of that, so that's doable. But it is significant time. We talked about the basics of the design process. So you start with requirements, you have a specification doc, breakdown of parts, role allocation, and adding things to the part library, which is part Google folder and part online. We've got different tasks, more concepts, printing time considerations. Oh wow, we can actually generate 3D printed pulleys. We have an OpenSCAD pulley generator, so if someone doesn't want to draw the pulleys but generate them in OpenSCAD, there's a link to that within the working doc. We've got force calculation, so that's the kind of motor we're actually using. And we're designing it for about a 200-pound tool force. That's pretty significant. 200 pounds of pull force using the NEMA 425 ounce-inch motors. Here you have GT2 belt information, general concept, the bushings that we're using, 2-inch inner diameter, and that's about it for the working doc. So part library, some calculations, bill of materials, accuracy, force, some other notes. So whoever's online, contribute to this. You can contribute to the part library, to editing the design doc by clicking edit under the working doc. And that document is open to the world. Under share, we actually have, if you click share, this is open for anybody in the world to edit that. It has also version history, so don't worry about messing things up in there. But that is editable by anyone in the public. So that's a brief overview of what we have on the 2-inch universal access. So please join us and follow the progress as we post information up there and files generated live to add to that. So thank you, and maybe you can contribute.